Lecture series we are going to discuss about the serial communication. So serial communication is nothing but a type of communication. So basic types of communications are serial communication, parallel communication. So here the data is transmitted sequentially over a single communication line, typically bit by bit. So bit after bit. So we are using here UART, ISART, RS-232, SPI and I2C. Serial communication is a method for transmitting data devices one bit at a time over a single communication channel like a wires or wireless link. So in widely it is used in the electronics and basically it's for its simplicity and low cost, and especially in embedded systems, microcontrollers and computer peripherals. Now you can see here communication modes, two types of communication modes where I have device A and device A. The data is transmitted serially one by one. Yeah, see here. But here the data is parallel, transmitted to the parallel. So here at a time all the data will be transmitted here, and in serial communication one by one it will be transmitted. So key components are asynchronous, no shared clock or device that use start or stop bit. So synchronizes no clock signal, so we have to use the start and stop bits like UART and RS-232. And if it is a synchronous, we have a clock signal to coordinate the data transfer, and we can find it in SPI and I2C, etc. And these are the faster but requires more wires. And next one here you can see a UART basics. So now we can get into a UART, which is the one of the asynchronous format, and here we know that in UART we need of a start bit and stop bit, and it is a hardware component that handles the serial communication by converting the parallel data to one serial stream and vice versa. And common UARTs are used in 8086, which includes 82450 and 16550. So key features is first one is baud rate. We have to consider the baud rate because it is nothing but the speed of the data transmission. Usually we have seen it in 9600 bps, etc. And data frame, they are typically 8 bits, and we have one start bit and one stop bit, and optionally parity. Registers, you will have registers for configuring the data and status like line control registers to transmit and receive buffers, etc. So interfacing, it involves configuring the UART sending and receiving data, and optionally handling interrupts for the synchronous communication. And here you can see for if in a UART communication, it's a serial communication, the data is transmitted one by one, and initially we have an start bit and also we have a stop bit, and these start bit and stop bit will be transmitted one by one in a serial communication. So we have a transmitter and a receiver part here. And next one is UART architecture. Yes, this is a basic in if we see an UART transmission, we have a transmitter device and the receiver device. And in transmitter device, we have the registers like to transmit the whole register. We have to hold the data which has to be transmitted, and we have a shifting operations to be incremented, and control logic depending upon the control logic it can be given or transmitted. And we have a baud rate generator which is used to generate the speed of the data transmission. And also in the receiver side we have a control logic to find out the sequence to be followed up. And we have a shift register, and one after one if we receive the data in a serial wise, we will be having a sequence counter, and it will be collected one after one, and the shift register will store the data received from the transmitter, and it will hold for some time to be stored in the register. So we have hold register, shifting register, and in between have a baud rate, and you can see the data will be transmitter and receiver to this internal parts. And now we are getting into the UART architecture. We have to know about the modes of communication. So we have three modes of communication. One is nothing but the simplex, that is we have a transmitter and a receiver, where the data is transmitted in a simple format from transmitter to receiver. No reverse format is seen here. We have a half duplex where the device acts as both the transmitter and a receiver, but not at the same time. If it acts as a transmitter, it will act as a other device will act as a receiver. And if the device acts as a receiver, the B device will act as a transmitter. So the one device will be acting as a transmitter or receiver, but not at the same time. In the full duplex, you can see the one device, that is for example if we have a device, the A device will act as both transmitter and receiver at the same time. It can act it will transmit the data, and also it will receive the data at the same time. And also in the B, you can see we have receiver and transmitter that will be also acting as the full duplex. So in a simple duplex, you can see only the transmission, the device will act as a transmitter. A half duplex, the device acts as a transmitter and receiver but not at the same time, and in the full duplex it acts as a transmitter and receiver and also at the same time. In the next lecture we will discuss about the UART architecture in depth. Thank you.